Global Green has been doing a lot of work since Katrina on green building and rebuilding the city. When we do that, we have to also recognize that New Orleans is a very susceptible city, and it's in harm's way because we are losing so many acres of wetlands per year. It's not about if we're going to have a hurricane, it's always when are we going to have a hurricane. And those wetlands are basically our soldiers. They're our front line. They take the storm surge. They take the brunt of that water from getting into our community. We wanted to start this wetlands program to really think about how we can innovatively restore our wetlands and get closer to having a restored coast in Louisiana.
Look at this. This used to be land. It makes me sick to see what's happening. And the reason that's happening is that we no longer have the sediment or the nutrients being supplied to this area by the Mississippi River. I've developed a device called the Wave Robber. The Wave Robber is a wave suppressor sediment collection system. It is designed to suppress the energy out of a wave and allow about 20% to go through. Okay? When that 20% goes through, we're actually slowing down the water. When water slows down, sediment falls out. It's accumulating and building the sediment. It's also preventing erosion. We're standing on the South Lafourche Hurricane Protection Levee, which is on the west side of the Bayou Lafourche. It's built to withstand hurricane-type water rises, but it's not designed for surges. The surges are controlled by the marshes that are behind us, but as you can see, we're losing our marshes.
We learn how to walk on the shrimp boats. I got my own generation of my children today that do the same thing. Try to make a living every day dealing with seafood that comes from Louisiana. That's some 10, 15, 9, 12s right there. That's what we get in our waters that come inside and mate. That's the big ones that have the babies for the little ones. But if you ain't got no wetland and no protection for them to move in at a certain time of the year, they can't mate and have no more babies, and when they do, they all die because they don't have nowhere to hide, you see? That means you can't produce what we used to produce years ago. Now this season here was a little rough, but normally at this time of the year, you got shrimp like this that sells for $4 and $5. Right now you gotta sell them at $6.50, the same merchandise.
This is what it used to look like when I was a young kid. This is going to be extinct if we don't do anything in the near future.
The quote right now is that we're losing a football field of wetlands every 40 minutes. The city behind me that you're seeing may be uninhabitable without wetlands. Wetlands are not only cool due to the fact that they protect our cities from storm surge and our communities from storm surge and our breeding ground for our fisheries, but they also take in a tremendous amount of carbon. So we're actually thinking about how can carbon offsets help restore coastal Louisiana.
A lot of what you see now are very degraded and falling apart cypress, or what we refer to as ghost swamps. So this is a very healthy cypress forest. This is one of the most beautiful cypress forests, I think, in Louisiana. Anything that's alive and growing sequesters carbon through photosynthesis. So it takes carbon dioxide out of the air, and the carbon in the carbon dioxide gets included in the roots, the leaves, the trees, But with wetlands, there's a unique carbon pool where there's a big soil component that builds up carbon. I would say that the implications of our work are really introducing wetlands as an area that industry can invest into to offset their emissions. So that opens up a whole new funding stream for wetland restoration. There was never a methodology to actually compare apples to apples, how you would design these systems, how you would monitor them, and how you would guarantee the quality of the carbon credits until last fall. In 2012, we introduced the first wetland methodology to the United States. So now that we have our first methodology, we wanted to apply that methodology to a pilot project. So this is our very first pilot project located in Luling, Louisiana. And one of the other reasons why there hadn't been a wetland methodology brought to market is there's still some gaps in the science.
Blue carbon is so new and innovative that there's not a lot of data out there. Recently, Global Green has partnered with LSU, Louisiana State University, and their School of the Coast and the Environment to work on a project in Lafourche Parish in southeast Louisiana. The applications for this research are going to start pointing to signs to say, is blue carbon feasible?
This is a navigational map of the Port Fourchon area. So we're gonna be over here for the lower, and then we're gonna go to the Champagne, Bay of Champagne, right here, this channel. And then the idea is that this is the area where you have the more marine influence and the tides. Over here, you're still having some marine influence, but the mangroves are beginning to go all this way up.
And the mangroves are expanding this
They
way.
are expanding this way. They have this large amount of production that actually fuels other so-called ecosystem services, like fisheries, other habitats. This site is one of the sites that we established to do this project about blue carbon. We have the mangrove in higher elevation, and then we have lower where some of the marsh plants dominate. Mangrove forests or mangrove wetlands are providing this source of organic carbon into the soil. And remember, mangrove forest is a type of wetland or forested wetland. Cypress, for example, are also forested wetlands. And they function very similar in terms of the carbon cycling like mangroves. I want to show you this. This is a residual of an experiment we did 4 months ago. It's a core, it's an intact core of the soil. We will say that we have a soil that is 40 centimeters in depth. This is the accumulation of the sequestration of organic and inorganic carbon that we are looking for.
We're trying to figure out how much carbon is in here.
We are trying to figure out how much organic carbon
organic.
it is here. This is an accumulation. Usually in ecology, depth gives you an idea of age of accumulation. So this is how it started going. So we can say that this is a very old carbon, maybe more than 40 years or 30 years that has been accumulating over here. So this is the below ground carbon. This is the above ground carbon, the leaves and the trees. We are recognizing the fact of climate is changing. Actually, because of the change of temperature, mangroves are expanding in Louisiana. The hypothesis is that mangroves will be replaced some marsh communities, as we are seeing right here. And we will see these species that have a stature of 3 to 4 meters.
We think that it's kind of interesting that here in the little bit more protected tidal creeks, we're seeing mangroves grow into larger plots.
So there we have more carbon above ground and therefore below ground that we have here. So the question that we have for these communities in Louisiana, in terms of hectares, how much carbon do we have at this moment accumulated in these communities? And how fast that carbon is decomposed and accumulate over decadal times as these communities within are going to start to grow like a full trees. So for us as end consumers, especially for fish or commercial fisheries, this question about how the habitat change and how that relates to the plant studies, including the physiology, including the productivity, those are important processes, ecological processes we have to understand with time to try to forecast how these plants are going to be cascading or affecting other type of processes. You know, unfortunately, some ecosystem services, they don't have monetary value. But really, in the economic sense, it's not that the ecosystem is part of the economic system. It is the economic system that is part of the ecosystem. So we have to try to establish a matrix, ways of measuring these services that have, as I mentioned, economical impacts in the long term.
We're also just starting to do this research, and it's showing us in the long term, is blue carbon feasible? Because if it's feasible, that means it can start financing coastal restoration.
Absolutely. We hope that our study here in Port Fourchon could provide science-based foundation that can help to develop these economic transactions in the future.